Bismillahirrahmanirrahim. Assalamu alaikum students. Last time we discussed the motion of charged particles in a uniform constant electric field. Today my topic is motion of charged particles in a uniform constant magnetic field, right? Motion of charged particles in a uniform constant magnetic field. So last time we said if a charged particle Q enters a magnetic field with velocity V, B denotes here magnetic field, then it experiences a magnetic force F given by this expression F is equal to QV cross B. So by the definition of cross product, this force F is perpendicular to V and perpendicular to B both, right? So that means this magnetic force is a deflecting force. It will always act perpendicular to the velocity of the particle, and since it acts perpendicular to the velocity of the particles, it cannot change the speed of the particle. So we must remember that the magnetic deflecting force has two properties that affect the trajectories of charged particles. What are the properties? First, it does not change the speed of the particles. The speed of the particles. Second, it always acts perpendicular to the velocity of the particles. So you need to remember these two properties. It does not change the speed of the particles. It always acts perpendicular to the velocity of the particles. Now, keeping these two things in mind, imagine there exists a magnetic field in certain region of space which is uniform and constant, Let me draw the figure. There is a certain region of space where there exists a magnetic field B. These crosses denote magnetic field. By that we mean the magnetic field is perpendicular to the plane of the board and it is into the board. So B is uniform, constant magnetic field perpendicular to the plane of the board and into the board, right? So I have a magnetic field in certain region of space which is uniform. That means the vector has same value throughout the space, and it's also constant. It doesn't change with time, and it is perpendicular to the plane of the board and into the board. Now imagine a charged particle enters, a positive charged particle Q enters this magnetic field with velocity v. So what will happen? This magnetic field will exert force on the charge given by QV cross P. Since the particle is positively charged, the direction of the force will be same as V cross B. So find the direction of the force. So V is this way, field is downward, and V is perpendicular to magnetic field. V is perpendicular to the magnetic field B. So what is the direction of the force? V is this way, magnetic field is downward. So if you do the V cross B, force will be this way. And that force will be perpendicular to velocity as well as perpendicular to the magnetic field. How? F will lie in the plane of the board and perpendicular to, it will be perpendicular to V. Since B is perpendicular to the plane of the board, it will be also perpendicular to magnetic field B, right? So V is this way, B is downward. When you use the right hand stick rule, you do the V cross B, then magnetic field will be this, magnetic force will be this way. And as particle moves, at every point force will be this way, and with the result, this particle will move in a circle. So this particle will move in a circle. This circle will have certain radius. Its speed will not change, so it will execute uniform circular motion. So the particle will execute uniform circular motion, right? Convince yourself that the direction of the force is as indicated, right? So it will execute the uniform circular motion, it will have certain radius. We will find that. Now, if r is the radius of the circle, radius of the circle, m is the mass of the particle, right? Then we know in uniform circular motion, a body needs centripetal force, and the magnitude of centripetal force is mv square by r. Direction of this force is towards the center at every point of the circle, right? Now here, this centripetal force is provided by the magnetic force. So we can write mv square by r is equal qvb. Why qvb? Is actually qvb, magnitude of force is actually q v b sine theta. Theta is angle between v and b. In our case, theta is 90 degree, v is perpendicular to b, sine 90 is 1, so it is just qvb, right? So we equate qvb with mv square by r. Solve for r. So r is mv by qb, or I can write p by qb. Let this be my equation first, where p is mv, which is linear momentum of the particle. From equation first, it is clear that the radius of the path is determined by the momentum p of the particle, charge, and the strength of the magnetic field, right? Now we can find the angular velocity of the circular motion, the angular velocity of the circular motion is omega equal to v by r, which is qb by m. And this be my second. The angular velocity of the circular motion is qb by m. And the corresponding frequency frequency is given by nu is equal to omega by 2 pi, which is, using second equation for omega, it is qb by 2 pi m. Let it be third. So it is my frequency for the motion, and circulate. So note that this frequency given by equation 3 associated with the circular motion does not depend on the speed of the particle. As long as speed of the particle is much less than speed of light c in vacuum. right? So that means if this charged particle Q in this figure is projected with a smaller speed, it will require the particle same time to complete the smaller circle that the faster particle will require to complete the larger circle, right? The frequency given by equation 3 is called cyclotron frequency. Right here, this frequency has a name. It is called cyclotron frequency. What is cyclotron? It is an accelerator that produces beams of energetic particles, energetic charged particles, which might be used in nuclear reaction experiments. And from this equation, we can see from this cyclotron frequency equation that the frequency is characteristic of a particular particle moving in a particular magnetic field, right? So this completes our discussion of this motion. I will give you first some questions as your homework. Question first. Question first says, a proton traveling at 23 degrees with respect to a magnetic field of strength 2.63 millitesla experiences magnetic force of 6.48 into 10 raised power minus 17 Newton. Calculate RT, the speed, and part B, the kinetic energy in electron volt of the proton. I repeat, a proton traveling at 23 degrees with respect to a magnetic field of strength 2.63 millitesla experiences a magnetic force of 6.48 into 10 raised power minus 17 Newton. Calculate the speed and the kinetic energy in electron volt of the proton. Remember, electron volt is a unit of energy. An electron volt is 1.602 into 10 raised power minus 19 joule. Also, 1 millitesla, Tesla is SI unit of magnetic field, is 10 raised power minus 3 Tesla, right? Let us move to next question. Question 2. An electron in a uniform magnetic field has a velocity v equal to 40i cap plus 35 j cap kilometer per second. It experiences a force F equal to minus 4.2 I cap plus 4.8 G cap femto Newton. Then question says if the x is 0, calculate the magnetic field. Right? I repeat the question. An electron in a uniform magnetic field has a velocity v equal to 40 I cap plus 35 j cap kilometer per second. It experiences a force F equal to minus 4.2 I cap plus 4.8 j cap femto Newton. If Bx is 0, calculate the magnetic field. Bx is what? It is the x component of the magnetic field. And you know 1 kilometer is 1000 meters, and is for 3 meters, and 1 femtonewton is 10 raised power minus 15 Newton. Femto stands for 10 raised power minus 15. Right? So this is your homework. Let us move to our next topic, which is the last topic of this unit first. What is that topic? That is the motion of systems of particles. Remember, we discussed the motion of a single particle. The question is how we describe the motion of systems of particles. If we have systems of particles, for example, you know, if I have a single particle of some mass m, I throw it, and this will be my earth. I throw this mass with certain velocity in the gravitational field. We know it will follow a parabolic path. Right? This motion you have already discussed in your previous class, studied, you have studied it well. This motion is called projectile motion. You know all the parameters of this motion. You can prove that its trajectory is parabolic. You can find its equations of motion. Then you can predict anything about it, like its time of ascent, time of descent, time of flight, range, etc. The question is, when we throw this mass, it is acted upon by gravity, and result is its projectile motion. We are treating it as a point mass in this whole analysis. Now, if I separate this mass into two masses, for example, I have one mass m1, second mass is m2, which is equal to m minus m1. Sorry, this might, let me make it clear. So it is m minus m1. That in other words means capital M is equal to m1 plus m2. That means I separate this big mass into two particles m1 and m2, right? m2 is capital M minus m1. Now if I connect, for example, these two masses by some spring, there is some spring, then I throw this combination of masses in the gravitational field, right? This is my Earth. I have these two masses, m1, m2, connected by the spring, right? And you throw this combination with some velocity in the gravitational field. The question is, what is the resulting motion and how to describe it, right? So what we do when we observe these motions, this is a case of systems of particles, not just single particle, two particles as a system are moving. So when we observe such motions, what we notice that individual masses may move in complicated fashion, but there is a one spatial point in the system of particles which is called center of mass. What is the property of center of mass? First, I give the definition of center of mass. Center of mass is a spatial point in a system of particles which under the action of external forces move like a point particle of mass equal to total mass of the system. Remember and understand this definition. I'm saying center of mass is a spatial point in a system of particles which under the action of external forces spatial point in a system particles which under the action of external forces move like a point particle of mass equal to total mass of the system. That means in this system of particles there will be some point called center of mass that will move like this capital M, because its mass is equal to sum of the masses of the particles. It will have a projectile motion like this capital M under the action of gravity. The question is how to locate it. So when we discuss the motion of systems of particles, we talk in terms of position of center of mass, velocity of center of mass, acceleration of center of mass, and then we apply Newton's laws of motion to this spatial particle center of mass, right? So the kinematics and dynamics of systems of particles is described by the kinematics and dynamics of this spatial point called center of mass, right? Now, how we write or express the velocity, acceleration, and the position of this spatial particle center of mass. I will first discuss only two particle system. Center of mass of two particle system, right? So if we have two particles M1 and M2, so remember, if you have two particle system, any two particles always lie on a straight line. So two particle system is always a one-dimensional system, right? Understand this? I'm saying if I have two particles located anywhere, they must lie on a straight line joining them. So if I have two particle system, it is a one-dimensional system. That means each mass will have a single position coordinate, and center of mass of the system will also have a single position coordinate. That means to locate the center of mass of a one-dimensional system, we need to locate only one position coordinate. So we take that position as x. So let x1 be the position coordinate of M1, x2 be the position coordinate of M2. So by definition, center of mass, xcm is here, position of center of mass of M1 and M2. So xcm, position of coordinate of center of mass of the system of particles, is given by 1 by m m1x1 plus m2x2. Let this be my equation 1, where capital M is equal to m1 plus m2 is the total mass of the system. Now, if we want to find the velocity of the center of mass, we have to differentiate first. So differentiating 1 with respect to time t, we get, I will write directly, velocity of center of mass VCM Let me make it clear. Is 1 by m m1 v1 plus m2 v2. Let this be my second, where v1 is velocity of particle 1, v2 is velocity of particle 2, right? To get the acceleration of center of mass, differentiating second with respect to time t, we get. So if I differentiate this equation second with respect to time, I will get acceleration of center of mass, and that is given by ACM is 1 over m m1a1 plus m2a2. So let this be my third, where a1 is acceleration of particle 1, a2 is acceleration of particle 2. So I encircle these equations. This equation gives me the position of the center of mass of this system. This gives me the velocity of the center of mass, and this equation gives me the acceleration of the center of mass. Now, if I have three particle system, let me write center of mass of three particle system. Now, if I have three particles, m1, m2, and m3. Now, three particle system can be, understand this, it can be one-dimensional, it can be two-dimensional also, right? So think about it. It cannot be three-dimensional. It cannot be three-dimensional. This thing I will tell you. Now for this, you think about at home. Think at home. So if I have three particles, I'm saying it can be one-dimensional system, it can be two-dimensional system, it cannot be three-dimensional system. See how? First two points I will tell you. Third one, you have to think. If the masses lie on a straight line, all the three masses are collinear, then it is one-dimensional system. So again, you need only one position coordinate for m1s, another position coordinate for one position coordinate for m2, one position coordinate for m3, and this term will have third term, center of mass of the system will have here m1x1 plus m2x2 plus m3x3, and one additional term here plus m3v3, and one additional term here plus m3e3, if all the three particles lie in a straight line, right? So it is in one-dimensional system. Equations are straightforward. One additional term will add in equations for second and third. Now, if they are not collinear, they lie in a plane, then to locate them, you need two position coordinates, right? So then it will have x coordinate, y coordinate. If you treat the particles in xy plane, M2 will have two position coordinates, x2, y2, and M3 will have two position coordinates, M3, y, sorry, x3, y3, right? And center of mass will also have two position coordinates. It will have xcm equal to 1 by m, m1x1 plus m2x2 plus m3x3, and similarly vcm will be 1 over m, m1v1 plus m2v2 plus m3v3. First I will tell you there will be YCM also now in the picture. It will be 1 by m, m1 y1 plus m2 y2 plus m3 y3. So this will give you x position of center of mass. This will give you y position of center of mass. Likewise, velocity will be in x direction as well as y direction. So if this is v1x, this is v2x, x component of the velocity of particle, to it is v3x, then it will be vcmx, x component of velocity of center of mass. Similarly, there will be y component of velocity of center of mass, which will be 1 over m, m1 v1y plus m2 v2y plus m3 v3y. v1y is y component of velocity of particle 1, v2y is y component of velocity of particle 2, v3y is y component of velocity of particle 3. Or you can club these two equations and these two equations, and likewise there will be two equations for acceleration. You can club them also using vector rules. For example, I will tell you these two. You can club using the idea of vectors and write RCM, position vector of center of mass, is 1 over m, m1r1 plus m2r2 plus m3r3, right? But RCM is position vector of center of mass. It will have two components, xcm and ycm. R1 is position vector of m1. It will have two components, x1 and y1, and same goes for R2 and R3, right? Likewise, you can club these two equations in vector form. You can write velocity of center of mass as vector and write it 1 over m, m1 v1, now v1 is a vector here, plus m2 v2 plus m3 v3, right? So now same goes for acceleration. Now I have told you, think about this, why three particle system cannot be three-dimensional, right? And when it is a system is three-dimensional, then it will at least have four particles in the system or more. There will be then ZCM also, or you can use the club the individual equations into vector form. Then vectors will have three components, right? I stop here and give you some questions related to it. I will give a simple question. This is your homework 2 now in the lecture, second homework. Question is like this. In first homework there were, let me use question 1. Question says, let me make the figure first. On this side is x in meters. This side it is y in meters. Then this is origin. So let me make the graph. Right? X is in meters, y is in meters. So here I have 1, here I have 2, here I have 1, and this point is 2. Now let me make the masses with another color. Use this color. So here I have 3 kg mass. Another color. Here I have 8 kg mass. And here I have 4 kg mass, right? This is my figure 1. Question says, where is the center of mass of the 3 particles shown in figure 1? Question says, where is the center of mass of the 3 particles shown in figure 1? And figure 1 is this. 3 kg mass is located at the origin. 8 kg mass is located at coordinate 1, 2. And 4 kg mass is located at coordinate 2, 1. So remember, it is a 2-dimensional system. So center of mass has 2 coordinates. So you need to find xcm and ycm in order to locate the center of mass. This all for today. Do your homework. Don't waste your time. Follow my video lectures. Make notes out of it. Don't forget to subscribe my channel. Thank you. Bless you. Assalamu alaikum.